All right, let's dive right in. So tonight's topic is skimming the text. So we'll take a look at some strategies where we can solve the problems without having to read every single word. But before we do that, let's do our weekly challenge problems. All right, so this first one is a probability problem. And we want, given that a student is randomly selected for Mr. Kim's class, that means we're only looking at Mr. Kim's class. So we can ignore all of this. All right. What is the probability that the student did not select a necklace? Okay. Well, notice all the problems have a one minus in it. And a one minus is related to something called the complement. So the probability of something happening, let's say there was a 20% chance that it was going to rain tomorrow. Well, that would mean that there's an 80% chance that it's not going to rain. So if you do one is like 100% in decimal form. So if you do one minus something is always, again, it's the complement. It's the probability of something not happening. So since they're doing it from that perspective, that's how we're going to do it. So we get the right answer. We want the probability that the student did not select a necklace. So we really want to do one minus the probability that they did select a necklace. And the probability that they select a necklace is C over 24, right? The number of people that selected a necklace over the total. So the answer is answer choice C. It's also important to note that another way to do this would be um, like not way this way. If this were open-ended or like in like a, I don't know, like an actual math class, um, it would be the probability that they did not accept the necklace would be bracelet and ring. So that would be A plus B over 24. But again, that answer is not there. They can't have two answers there. That would have been another way to look at this problem, but we wanted to look at it from the perspective of the complement because every answer had a one minus in it. Notice that answer choice A has A plus B over 24. That's a common wrong answer because students want to do the A plus B over 24, but the one minus wouldn't make sense in that case. All right. Number two, this one is a pretty tricky problem. What we have to do for this one is really just kind of sketch out a little bit. We don't need the actual coordinate plane, but the idea is let's just say this was line J, and that's tangent to circle Z. So that just means Z is the center. The idea would be that the radius is perpendicular. So tangent means two things. It crosses at one point, and it's also perpendicular to the radius. All right. And then let's just say line K. Again, it doesn't really matter, whoops, where these are. Let's call this line K. That would also be perpendicular to the radius. So basically, what ends up happening is you end up with the idea that this line, we have to find the perpendicular to this line and the perpendicular to this line, and they intersect at the center of the circle. Okay. So the way we're going to do that is we're just going to find the equation of each line. So let's call this one line one. So line one is going to be perpendicular to line J. So therefore, it's going to have a slope of positive 3/4, the negative reciprocal, and it's going to go through this point, negative 810. So if I use point slope form, that's y minus 10 equals 3/4 times x plus 8. Um, and then if if I also you find the equation of the second line, sorry, that one is going to be perpendicular to this slope. So that's going to have a slope of negative 4/3, and it's going to go through the point. So we'll call this is line two. So we'll call that point. So that's going to be y minus 3 is x plus 9. All right. So let me just recap that. Line one is perpendicular to line J because it's the radius. All right. And that means perpendicular is going to have a negative reciprocal slope and go through this point, and I just plug that point into point slope form. And point slope form, if you are unaware or haven't done that in a while, that is this. I'll explain why that's useful here in a second. So then um, we do the same thing here. So line 2 is perpendicular to line K. So I did the negative reciprocal of line K, and it goes through this point. Now, what happens is the intersection of these two lines should be the center of the circle. And the center of the circle is our A comma B. All right. So what we're going to do is I need to open up. We're going to do the rest of this in Desmos because trying to find the intersection of these by hand is just a lot of unnecessary work. So I should have had Desmos loaded up here, but I do not. So let me load up Desmos, and then I'll show you how we can just plug that in and get our answer pretty easily. All right. So now I'm going to share my Desmos. So I'm going to put in the first equation, which is y minus 10 equals 3/4 times x plus 8. And then the second one is going to be y minus 3 equals -4/3 times x plus 9. All right. And then we want to find where these intersect. They intersect here at -12/7. All right. So let's remember that. -12/7 is their intersection. And then, whoops, I just shared the same thing. So the intersection, which would be the center, would be -12/7. So -12 is A, 7 is B. And if I add them together, finally, I get the answer of -5. So -12 plus 7 is -5. And that is the answer to the problem. Okay. Let's now move on. That was our challenge problems. So now let's move on to our idea of skimming the text. So this strategy is simply just how can I do the problem without reading every single word? So what we're going to look for is equations and other things that are going to help us solve the problem without reading every problem. So I have an equation and I have a point. If you are ever given a point on the SAT, almost every time, just plug that point in. All right. So right away, A goes in place of X, B goes in place of Y. I haven't read the problem yet. I don't really care at this point. I just know if they give me a point, I'm going to plug it into the equation that they gave me. Okay. And then I'm just going to read the question. What is the slope? All right. Well, we should know that the slope is in this position. We're used to y equals mx plus b, but they like to switch letters around and stuff. We got to know things more generally than specifically. So we know that the coefficient of x is the slope. So that's k. So we just get k by itself. So add 3, divide by k, or sorry, divide by a, get k by itself. So it is b plus 3 over a. All right. There's a lot of extra words in this problem that we do not need to worry about. We need on this new version of the SAT more specifically than any of the older versions. The problems, they're taking easy problems and then doing certain things to make them look a lot harder. So the less that we can get bogged down at all that kind of nonsense that they're doing, and the more that we can just say, I am just going to find a way to get started and then let kind of the algebra just kind of lead me right to the answer. Okay. So again, I do not care about any of this. When you see an equation, this kind of problem is called a literal equation. You see an equation that has a bunch of variables and constants in it, and then all the answers are those same variables and constants solve for one variable. All that's doing is saying, solve this for S, rearrange to get S by itself. I don't care about the expected time to complete a marathon. All that extra reading just wastes time and gets your brain thinking about other things that are not important. So just take this, get S by itself. So the first thing I would do is square both sides. So E squared equals S squared plus 2F over A. Again, I'm trying to get this by itself, so I would multiply each side by A. So that's E squared A is equal to S squared plus 2F. Subtract 2F, E squared A minus 2F equals S squared. I would stop there. You have to square root both sides. So that's got to be A. So the earlier in these problems where you're doing algebra that you can stop the problem and still figure out the answer. It's a balancing act though, because you don't want to stop too early and do too much in your head and get the problem wrong. But you also don't want to, you don't need to finish the problem. You're not showing this work to anybody. You just want to know that, well, if S squared is this, then the answer is the square root of that. All right. And the other key is not to read and wasting your time worried about some marathon race. All right. So another one. So in this type of problem, we have a word problem. Again, I don't need to read the whole thing. I have a I have an equation that is in like looks kind of like y equals mx plus b, but it's written like this. All right. And then they just want to know the meaning of the number 42. All right. Well, notice 42 is like a B. It's rearranged with different letters, but it's still the y-intercept. And the y-intercept always is the value of the y variable when the x is 0. So all I want to do is search for what is the x in this problem, which is D, and D stands for days. So that's 0 days, right? I want the X to be 0. And the Y is really the W. And the W is the number of wills. So that must be 42 wills. So I'm looking for a problem that talks about 42 wills at 0 days. So 6 wills, that doesn't make any sense. 42 wills, but per day, that doesn't really make sense. The word per is more associated with the slope, and that's -7 in this problem. Finish for wills in 42 days. No, it should be 42 wills because again, the 42 is the y-intercept, which should be using the units for the y. And that leads us to D. Starts each week, right? 0 days have gone by. That's the start of something. And again, even I wanted to go over that even more generally, but for harder problems. But the reality is a y-intercept is in a word problem is or a real world problem is going to be um, either starting or initial or beginning value. So even just the word start tells us that. All right. We got another one like that. So again, I don't really care about all this. I have an equation that looks like it's in slope-intercept form, just with different letters and rearranged. And I want to know what 16.8 represents. Well, 16.8 is the coefficient of the variable. That's the slope. All right. So 16.8 represents the slope. And slope is rise over run. So what I really would like to know is what are like the units? The rise is the change in y, and the y here is the p. All right. So that represents average number of points per game. Okay. So that's what the y is measured in, average points per game. And the t is represents the number of years. All right. So it's the average number of points per game. Um, per like I guess per each year, right? So that is the yearly increase in average number of points per game. That's C. All right. So again, what I you might have even been able to get that. I'm trying to go over a more general way for some of the harder problems. So again, when you know something's a slope, we just need to know the unit. So the rise is the y, which is the average number of points per game. and then the run is the number of years. So that's the yearly increase. All right. So as the years change, the number of points per game changes. All right. Or if you just look at total, doesn't really make sense for slope. Average number of points John scored per game in a single year, that doesn't make any sense. And the average number of games played, that again doesn't make any sense because this isn't talking about the number of games played. All right, let's keep going. All right, so again, we have another one where we just have an equation. And what is the increase in weight of the tire for every second the pump is used? So again, they're asking about the increase. That's the slope. Now the slope is 0.4. Now I just want to be careful. Let's remember that again, that's rise over run. That's the unit of the Y. So that's W, which is the weight. All right. That's in pounds over whatever the X variable is, which is S. So that's in seconds. All right. So that's zero point 0.4 pounds for every second, which is exactly what they're asking. What's the increase in the weight for every second? All right. So I just want to go over that again. The answer may not always be the slope because they might have asked for the increase in weight for every like 2 seconds or something, and then we would have to adjust it. I just go over the units just to make sure that that's all that like that it is in fact the slope is the answer. Okay, so here's another type where they give us an equation and they just want to know what a specific coordinate means. So again, I see an equation, I skip all this. I want to know what a specific coordinate means. So that means the 5 is the x and the 0 is the y. I just want to know what units they're measured in. So 5 is the x. X is in weekly withdrawals, right? X weekly withdrawals. Um, so that is simply um, and Y is the dollar amount left. All right. So this is weekly withdrawals or weeks. And then 0 is the Y, which is dollars. So I'm just looking for some answer that talks about 5 weeks and $0. And that happens to be A. The coin collection will be empty. So $0 after 5 weeks. Withdrawals $5. Well, $5 doesn't make sense, and $4 doesn't make sense, right? There should be $0. And again, you don't need to read the whole problem. You just need to know what does the X unit and what is the Y unit, and then we can find that answer. All right, so we got another one. I don't really care. I mean, I care about, Saturn's moon and stuff. That stuff is fascinating to me, but I don't care when I'm taking the SAT or doing an SAT problem. What I care about is I have an equation and then I want to clearly get D by itself. All right. So I'm going to do that by dividing by 18. Okay. So I'm clearly dividing H by 18. So I'm going to get rid of these two answers. I'm going to, again, try to do this in the least amount of work possible. Now I want to get rid of the cube. So I'm going the cube root, my bad. So I'm going to cube everything. And then I can pretty much stop. I'll go one more step. So I have H over 18 cubed. And right, so that gets rid of that. So I want to get rid of the fourth power. So that means I got to raise it to the 1/4 power or take the fourth root, which really just makes it like that. All right, so we should know that when you take the fourth root, that's the 1/4 power. So that's why the 4 just kind of goes on the bottom there. All right, so then that tells me that I have to have 3/4 in my answer. So it's got to be D. All right, so not only are we trying to skim the problem and read as little as possible, we're trying to do the least amount of work to get the right answer, right? The time test, we want to use all the math concepts. These are not tricks to replace the math concepts. You have to know the math concepts. You have to know how to rearrange and you have to know how to use rational exponents and all of that. But once you know all of that, then the name of the game is let me do the least amount of work possible so that I can get the problem correct and then move on to the next one. All right. So these aren't tricks in the sense that they're going to let you figure out the problem without knowing the math. You have to know the math really well, and then you can execute these tricks in the quickest way possible. All right. So again, don't need to read the problem. Clearly, I'm getting F by itself. Now, this one's a little tricky. Some students have problems with this because the thing that I'm getting by itself, F, shows up more than once. So I'm going to multiply each side by n plus F. So I get, and then I can distribute. So that's Rn plus Rf equals, so this cancels. So I get that equal to F. And what I want to do is if I want to get F by itself, um, then I want to get the F's on one side and like the non-F's on the other. So what I'm going to do is I'm going to bring this RF over to this side. So RN does not have an F in it. So I want that to be on one side. And then this RF, if I bring it over, I'm going to have to subtract like that. And the reason that I do that is since each this side has only terms that have F's in it, I can then factor the F out. So Rn is equal to, if I take the F out, I get 1 minus R. And then again, I'm going to stop there and I'm going to say, okay, to get F by itself, I need to divide by 1 minus R. And I need to have an Rn in the numerator, so that's B. All right. So I need an Rn in the numerator, so A could have worked, but it doesn't, but I'm not divided by R minus 1, I'm divided by 1 minus R. Okay. Number 9. All right. So now I'm going to look at my answers and see that every one of them has a less than or equal to 50. So I don't really care about the 50. All right. So then I am going to maybe just read this sentence. So it includes a $20 monthly fee and an additional charge of 75 cents for every hour. So if it's a $20 monthly fee, when there's a fee, that usually just is the number that shows up by itself. And then the additional charge per hour, that's what's being multiplied by the variable. So given that, only A makes sense. All right. So again, we kind of get this by just reading one sentence out of the problem. Number 10. So we have another problem where we have an equation and we want to know what something represents. So here, this is a different type of one. This one is in standard form. So what we want to do is pretty much locate the x is being multiplied by 25. All right. So that is, there are classrooms with, so I'm going to go back and read just the part with the 25. So there are classrooms with 25 students each. All right. So first of all, it has to be it has to be something that has to do with 25 students. So B and D are out. All right. Um, so then we say, is the number of classrooms with 25 students each, does that make sense for X? So let's say X were 2, and I did 2 times 25. Well, if there were 2 classrooms with 25 students each, then it would make sense to do 2 times 25 or 3 times 25. So that one looks good. I would just check the other one. The average number of students per classroom with 25 students. That doesn't really make any sense. The average number of students per classroom. So that would be like, let's say a classroom had 20 students per classroom. And then with 25 students, yeah, I don't even understand the wording of that. So I'm going to get rid of that. So the answer has to be A. All right. Again, we still have to do thinking, but we just don't need to be bogged down with the other parts of the problem. We just need to think logically about just that part of the problem and what would make the most sense. All right. So it's got to be the number of classrooms with 25 students each. Okay. All right, number 11. Here is a different type of problem that we should, or a different function or type of function that we should be aware of. So we're doing a lot of linear functions. Now all of a sudden we have an exponential function. So what you should know about an exponential function is that the number in the front represents our initial value because that's, again, when your input is zero, you'll get this number in the front. And this number here has to do with some kind of like percent increase or decrease. So we don't really need to worry about that in this problem because they want to know the interpretation of 115. So all 115 is it's the x, or sorry, it's the y-intercept or the initial value. So I see the word original, so that makes me go to that one, but it's definitely not a decrease. It's not the number of days that has been in existence, and it's not a percent decrease. So it is definitely A. It's the original, the beginning or starting amount. So again, we can't get that if we don't understand that when you have something in this form, y equals ab to the x versus y equals mx plus b. All right. So you have to be able to identify I have an exponential function, I have a linear function. When I have a linear function, this is the y-intercept or the initial value, and this is the slope. This is the rate of change. Then you have to be able to identify when I see an exponential function, this is the y-intercept or the initial value, and this represents some sort of like percent increase or percent decrease. All right, number 12. All right, so we have an equation again. Doesn't necessarily matter yet. And then I would go to read the problem. Which number represents the height of the building in meters from which the ball was thrown? Um, well, then I would go back and just look real quick. H is the height, T is seconds after it's thrown. So all I care about that. T seconds after it's thrown. Well, when it's thrown, that's 0 seconds. That's the beginning of the problem. So I just got to plug in zero for T. So that's gone, and I just get 20. So that one I ended up reading more of the problem. Another point of the strategies that I like to go over is that they don't always work. So there are problems where you do have to read the words. So this one we needed to read more of it than we probably didn't. Um, but it still helps to get out of the habit of reading everything through and then being like, I don't really know what I just read. And then you're just wasting time. All right. So even though we did have to go back and understand the problem a little more than some of the earlier ones, it's still a good habit to go notice an equation, go right for the question. All right, this one I put in here. This doesn't always work, so I can go over the problem more. We can look at this two ways, but honestly, when you see something like this is the equivalent of them giving you a point. We have to look at this and see this, right? That's the same thing. They give you a point, plug it in. Just plug it into all the answers. If X is 1, the P of X has to be 30. Well, if this is 1, 30 times 0.25 is definitely not 30, and 30 times 0.75 is definitely not 30. 40 times 0.25 is 10, not 30. Then you just get this answer. You didn't even have to read the rest of the problem. But just to go over those concepts, because we should understand where this is built from, um, a 20 if it decreases by 25% every time X increases by one, decreasing by 25% means we're keeping 75% of it. So that's where this 0.75 comes from. So you got it in percent problems, look at it kind of that way. When you take 25% away, you're keeping 75% of it. And then the number in front, this is what I talked about on the other problem. That's the initial value. The initial value is when your input is zero, not one. So if the initial value is not 30, then it must be 40. All right. So again, we can get that problem, but the way this one was made was like all we needed to do is just start plugging this in and we get the answer. So it's worth doing that. And then if it's down to two answers, then again, you have to read probably even left because you don't have to decide between four answers. You just have to decide between two. And then this one we get lucky because it just gives us that one answer. Okay. Number 14. So again, we have an equation. So I just noticed, all right, I have an exponential equation. So my brain starts thinking exponential. All right. It wants the interpretation of the y-intercept. All right. The y-intercept is the number in front. So the y-intercept is 12,000. So this is gone. This is gone. I need to be talking about 12,000. Okay. Now, to further understand the problem, in general, a y-intercept is when the input is zero. Well, the input is s. Well, what does s represent in this problem? I just need to go. S it literally tells me here. I just find it. S represents the number of months since January 2015. So this must be have something to do with January 2015. The estimated number of downloads the artist had in January of 2015. So that's the answer. The minimum estimated number, they're just making stuff up there to distract you. All right. So again, equation, what type of equation is it? Is it a quadratic? Is it an exponential? Is it linear? Right? They're the three main types of equations we have to know for the SAT. And when they're talking about a y-intercept, we have to know where that is. So the y-intercept is right in front for an exponential function. And then we just need to know what's when the input is zero, what is the input, right? In this case, the input is the month since January 2015. So that has to be in the problem, and 12,000 has to be in the problem. Okay, number 15. All right, so again, equation, linear. Best interpretation of 800. 800 is the y-intercept. It's the constant, not the coefficient. So boom, I know right away that I have a y-intercept. And I then want to look at, well, what is my input and output, I guess. So input is m. So I know m should equal zero. All right. So at 0 months, I have 800 what? Dollars. Okay. So before Maya made any monthly deposits, the amount in her checking account was 800. Right. The first one with each monthly deposit, the amount is increased. No, we're not increasing by 800. 800 is this fixed amount that we start with. After 1 month, note, has to be 0 months. Maya made a total of 20. That doesn't make any sense. All right. So again, we're using our knowledge. It seems like we're taking all these shortcuts. So I'm not saying that we need to just like not understand this stuff. The only way to be able to do this is to truly have a deep understanding of it and to know the types of equations and to know them so well that you know exactly what each number in that equation is telling you, and then you know what to search for in the problem. So again, you're not like trying to understand what Maya is doing in this problem. We're simply just looking at the equation and we know exactly what we're looking for. All right, that brings us to the last problem. And this one we have an inequality. Um, so again, this is just some inequality. It doesn't really fit the mold of the other problem. So, but again, I just noticed I have an inequality. It says if the hotel accommodates 15 cats. Well, I could probably guess that cats is C. So I'm just going to plug in 15 there. And then I'm guessing that again, some of these problems, you only have like one logical thing to even do. Just get D by itself. Subtract 60. 40 divided by 3 is 13.3 repeating. Okay. So now let's answer the question. What's the maximum possible number of dogs it can accommodate? Well, if it has to be less than 13.3, then the most it'll be able to accommodate is 13. Okay. So again, we don't need to read everything. We can locate equations and just locate certain parts of those of certain words throughout. All right. That's a skill that is important because it not only wastes time by reading every word, it also gets your brain thinking. Your brain is naturally just going to try to figure stuff out no matter what you feed your brain. So only feed your brain the things that are actually going to help you solve the problem. Your brain doesn't need, not need to understand like what's going on with this hotel and what Maya is doing saving money and why is she saving money. We don't need to know any of that. We need to be very direct when it comes to this because you only have limited time in these problems. All right. Especially when you get to the second module, which is going to be hopefully harder if you get the hard second module. And then you're going to feel like you have even less time because the problems are going to be harder. So you need these shortcuts on the easier problems and the harder problems. Okay, that is it for our office hour tonight. So just make sure you check us out on TikTok. I will post all the challenge problem solutions, and plus a lot of these solutions I will like splice up and throw there. I'll put this whole office hour on YouTube. Anybody interested in one-on-one math tutoring, we do that. We have full-length digital practice tests. Call or text or email. All right. Thanks again for attending and or watching this. Have a good night. I hope that was helpful.